everybody. I have 2 o'clock p.m. Eastern Daylight Time, so this is the appropriate time to start this presentation. I want to thank everybody for joining us today. This webinar topic is called Pervious Concrete Design, and it is offered by the National Ready-Mix Concrete Association. A little bit about us: we are a national trade association, and our members are ready-mix concrete producers. Some information here. As far as our website for our members, if you're interested in becoming one, we have memberships not only for ready-mix producers, but we also have non-producer memberships, and there's lots of great services that we can offer as a member of the National Ready-Mix Concrete Association. So if you are interested, I encourage you to go to the website or reach out to one of the people who you're going to be seeing on this webinar today. I'm going the wrong direction here. Today, your presenter is myself, Ken Justice. I am a professional engineer. I've been promoting concrete for both the Portland Cement Association and the National Ready-Mix Concrete Association since 2005. I figured out today that this presentation I'm giving you on Pervious Concrete, I've given over 350 times in 15 years. I am a certified National Ready-Mix Concrete Association Pervious Concrete Craftsman, and there's only 22 of us in the whole world. Not joining us today, but who unfortunately had prior commitment, is Senior Vice President Phil Kresge. He is one of the administrators of our Pervious Concrete program, and Phil is also an excellent resource when it comes to Pervious Concrete. Also want to thank our super sponsors. As you see here, Sika, BASF Master Builders, Euclid Chemical, and GCP Applied Technologies for their support in this webinar series. The disclaimer I'm not going to read the whole thing to you, but just understand that this presentation is prepared for information purposes, and please use it accordingly. I'm not a lawyer, so that's the best way I'm going to explain that to you. Just some housekeeping items. This webinar, everybody's going to be muted. You can ask a question by typing it in the question box that should be a part of your logging into this webinar. There are downloads if those just came on late. If you go to the handout section. This presentation is completely in a PDF that you can see. But in addition, there's other brochures you can use and the design program, which I'll be touching on later. I'm going to give that to you for free today. At the end of this course, you will get credit for it based on not only your attendance, but there's a quiz, and then you will get a follow-up certificate. It's usually an hour after the webinar has been completed. And you will receive 1 professional development hour or 1 continuing education credit, or whichever one your organization honors. Here are the learning objectives that we're going for today, but really this is all on the agenda. And when you start to ask and think about questions, a lot of you have some preconceived questions about pervious concrete. And for the 99% of the time I've given this presentation, the 3 questions which you see here on the bottom right are the ones everybody asked. So we will touch on those. Those people attending this webinar in places that do not have winter weather, just bear with me. When I've given this presentation in Hawaii and in Florida and Southern California, I usually skip through those, but this is going out to, at the moment, almost 400 people or 300 people. So we will touch on all these subjects here. I will tell you this, that there's a lot to cover in 1 hour, and some of the slides I'm going to breeze through because this is the first of 4 Pervious Concrete webinars we'll be giving. And next week, we're going to be giving a webinar that'll delve much deeper into the concrete mix and into maintenance. So while I'll touch on it today, if you attend next week, you'll get a much better explanation of those items. So let's get into this. So let's talk about what pervious concrete is. And every time I give this talk, either to contractors, to owners, to engineers, the first thing I want everybody to understand is, even though this is titled Pervious Concrete, I need you to retrain your brain and take the word concrete out of this, because this really is a brand new animal. And a lot of the mistakes that we find in pervious concrete design especially is that engineers think they can take a regular concrete spec, write the word pervious in front of it, and send it out. And this really needs to be a different thought process. Much like I explained it when, if you ever design something in metric as opposed to imperial numbers, you have to retrain your brain to think in metric. I want you to retrain your brain, because even though this is concrete, this is a completely different product in how we design it, how we batch it, how we deliver it, how we install it, how we specify it, how we maintain it. Why that is we now have a product that isn't just a pavement. This is actually going to be a stormwater management system. And I need you to think in those lines of, you're not just designing something to drive on, you're designing something to not only drive on it, but will also deal with your stormwater. Now, pervious concrete has been called several things over the years. It's been called no fines concrete, popcorn concrete. But really what we have is a ready mix concrete product where we take the fines, the sand out of the mix, and we deal with one size of an aggregate and the cement paste. And because of that, we will have a void structure that will allow the water to flow through it. First thing I want you to understand is what it looks like. What you see on the left is a regular broom concrete like you'd see every day. On the right is what we call pervious concrete, and I call it a Rice Krispie treat texture. It definitely has an aesthetic that is much different than what a lot of people are used to. Now, where do we use it? One thing I'm going to show you throughout this presentation is photos of projects that I personally worked on. I said I'm a craftsman. I stopped counting after 200 projects I've worked on personally. And you're going to see I'm based in Philadelphia, Pennsylvania, so a lot of these projects are close to where I live, but I have promoted and worked on projects all around the country. We use pervious concrete mostly in parking lots. However, more and more I'm getting phone calls for personal projects in people's driveways and sidewalks. I have a lot of municipalities, including DOT, such as in Delaware, that work almost exclusively now with pervious concrete sidewalks. We can also use it on roadways, but you'll see mostly in the United States it's used on not highly traveled roads, such as alleyways, cul-de-sacs, residential roads, and that has all to do with the maintenance component, which I'll be touching on later. We can get this strong enough to handle highway traffic, and in Europe they actually do use it on highways, but the only time we really see heavy-duty use is places like loading docks. A lot of power companies have lay-down areas. I know of a truss factory that did several acres of it. With this industrial mix, we have a heavy-duty mix. It's a little bonier with larger aggregate. You'll see that it's not really conducive to people in wheelchairs or women in high heels, but it is a very strong mix. I can get this strong enough to handle the heavier traffic. We're also seeing a lot more calls for patios and pool decks. This is actually my house right here, and there's my lovely dog. I don't know why the video isn't working, but that should be a video. There we go. Of the water going through it. That was my daughter from about 6 years ago. And I get several neighbors now, and actually the township I live in is starting to use this more and more. You'll also find that when you use pervious concrete, because it is an open graded mix that allows air and water to travel through the pavement, you can save trees. You will not have the tree roots dying because air and water will get to the roots. And in fact, if you've ever seen trees pop up the pavement, an impervious pavement, it's doing that because those roots are looking for air and water. But with a pervious concrete system, air and water will get to the roots. So the roots will not come to the surface. It will not pop your pavement up. Because of that, we found many of the states have approved the use of a pervious concrete in their parks for pathways. We see golf courses use it. We see a lot of nature parks use it. I'm showing you two pictures here. On the left is a park in northern New Jersey. On the right is a park that's down the Jersey Shore. We'll be touching on both of these parks later on for a good reason. So keep that in the back of your mind. My computer's locked up here. There we go.
Yeah, I see the screen moving.
I'm having some technical problems here.
Yeah, those videos may cause some issues, but it's currently moving right now.
All right.
I can see it.
Can you see it now?
Yep.
All right. Hopefully this is showing up. Well, this is supposed to be a video that will show a mixer truck dumping the water and it disappearing in about 30 seconds. And the point of the video was to show that a pervious concrete pavement system can drain anywhere between 275 to 1,500 inches of rain per hour. And to give you a comparison, in New Jersey, the 100-year storm, which is the worst storm event you'll get in a century, dumps around 9 inches per hour. So this system can handle a lot of water. I apologize for the technical difficulty with the video. Now, benefits of pervious concrete. Remember, this is a system, and we're looking to replace or at least drastically reduce the size of other forms of stormwater storage, such as underground storage pipes you see on the left, or an actual detention or sometimes retention ponds. And why this is important, especially in cities where land is a premium, to be able to eliminate these by actually paving over them and making that into usable parking space, yet still having the same storage and benefits of these ponds, makes pervious concrete a very, very popular item for people that understand how to design it and how to use it. And the reason that is because, remember, we're taking the word concrete out. We're rethinking this. This is a system. And the complete system consists of a layer of pervious concrete. Below that, we have a layer of a clean aggregate. Most common, it's a 3/4 inch stone. And that is called the recharge bed. The water actually goes through the concrete and sits in that stone layer. And then the next part of it is it absorbs into the ground. So we need ground that has some perk value, some permeability to it. One of the things I'm going to recommend now, if you're thinking about using pervious concrete, is when you have a geotechnical analysis done on the soils, you're also going to need to have a perk test run so you can get a permeability of the soil, because we're going to need to know that. Now, one of the problems we have when we pave, especially large parking lots, is there's very little, if any, absorption of the water into the ground. The stormwater paradigm is to put the water into inlets, which go to pipes, which then go to a pond, which then is controlled release into some other body of water. And by doing that, we have now taken Mother Nature's way of recharging the groundwater and giving life to the local flora and fauna. We've taken that away. And then we all too often pave these large parking lots in a dark colored pavement, which actually absorbs heat, which then makes the surrounding area hotter. And then we have oils that drip off cars, we have pollution, we have erosion, and all of that ends up getting into the pipes, which get into the ponds, which eventually get into the streams. In effect, we do have an environmental issue that needs to be dealt with. And praying this video works. Follow the duckies here.
Went down our storm drain. When it does, it's trash, oil, cigarette butts, and pet waste flowing untreated to our waterways. Clean water It's up to you, New Jersey.
So every state in the country has to deal with pollution from stormwater. And they put together what's called best management practices and how to deal with that. And there's many different ways you can deal with stormwater, both quantity and quality. Why we love a pervious pavement so much is that we can accomplish so many of the best management practice goals, yet still have a pavement that can be used to drive on, to park on, to walk on, to play on. What's great about a pervious pavement, water, when it rains, can go back into the ground and recharge the groundwater. And at the same time it's doing that, it's getting cleaned. So we're not only controlling stormwater quantity, we're controlling the quality. And then let's add some benefits that concrete is a light colored pavement. And because it's open graded with all those voids, it actually dissipates the heat instead of absorbing it. So it helps cool the communities. And will it absorb water? Good, this video is working. That's not a garden hose. That is a concrete mixer truck dumping water, and you can see how quickly it disappears. And let's just hope we never get a rainstorm that dumps water like that. Now, if you're wondering if your state approves of pervious pavements, if you look at your Department of Environmental Protection or whatever your state agency is called, you'll find that every single state deals with best management practices and does have a section dealing with pervious pavements. Now, there are three types of non-proprietary pavements that are out there, pervious pavements. There's a concrete, there's an asphalt, and there's a pavers. There's pros and cons to all of them. I will tell you unashamedly that concrete is the best of all the worlds as far as performance and price and durability. We could get more into that. If you want to email me later, I could give you pros and cons of all of them. I also offer webinars at times and we delve into all three of them. But today we're going to stick with the concrete. What the EPA, Environmental Protection Agency, and most of the states are most concerned with is we call that first flush. When it hasn't rained in a while, and that first gush of rain will have the highest concentration of pollution. And when we deal with best management practices, they are really dealing with that first initial burst of rain with the highest concentration. And what we found is that pervious pavements do a very good job of dealing with that pollution through a combination of what we call filtration and microbial conversion. Now let's touch on the filtration real quick. The water gets filtered through the concrete, through the stone base. We have a geotextile filter fabric, and then the earth. It's very similar to the filtration that's done if you have a septic system at your house. The second part of this is what we call microbial conversion. There are bacteria that exist in nature, given air and water, will breed, and we've actually found that they actually build these colonies on the geotextile fabric, and they will eat up the hydrocarbons, the oils that come through here and emit oxygen, very similar to photosynthesis with the trees with the carbon dioxide conversions. As long as you don't flood the system. If you had you should build a 5,000 gallon oil tank, that won't be clean, but the concentrations that we see in that first flush get handled very well, and you can see some of the percentages right here. And these are numbers that we get from the EPA studies that are out there if you want to Google those. Now, the mix itself is a very simple mix. And here's the most important thing I want you to get out of this slide. When it comes to pervious concrete, we do not ever spec it by compressive strength. You don't call up and say, I need a 4,000 PSI pervious concrete. The reason is there is no ASTM test method for compressive strength of pervious concrete because it's such a different animal. Pervious concrete is actually specified by unit weight and void content, and typically we are speccing 20% voids and around 127 pounds per cubic foot for density. And that's how the pervious is spec'd. Now, I will tell you that from doing enough cylinders and enough brakes that we do get a typical mix that's not altered is somewhere around 2,500, 2,800 to 3,000 PSI. We can get stronger mixes, and I'll touch on that in a minute. But remember, we are not specifying pervious concrete because of its strength. We are specifying it because we want it to absorb water. It is a system here. So just keep that in mind. I get that a lot. Like, what's the PSI? What's the PSI? And I remind the engineers, that's not why you're using this. What a mix typically consists of, it's around 500 pounds cementitious. We can substitute some of the cement with fly ash or slag. You don't want to get too much because it'll affect how the mix comes out of the truck. Around 2,700 pounds of a coarse aggregate. The most common is 3/8, and I'll show you in a little bit how you can change the size of it. Whatever we spec, though, it has to be consistently sized. We can't have several different sizes in there. The most important part of pervious concrete mix is getting the water to cement ratio correct. This is a much drier mix than regular concrete. It's going to come out much slower. About 40 minutes to dump a 10-yard truck. I say it comes out of a truck like soft serve ice cream. Yet it must have the right water to cement ratio to make this work. And that is right around 0.33. If you're not familiar with water cement ratio, it's basically just a ratio of the pounds of water to the pounds of cement per cubic yard. And in pervious concrete, because we're taking all the fines out of it, the only way we get strength with our mix is through the paste. So that's why we have to reduce the water. I'm not going to touch too much more on this because it's going to be covered a lot next week in the next session of our webinars here. I'm leaving the slides up so you can refer to them if you're not going to be attending next week. One thing of the slide you see right now, there is a difference in definitions when it comes to permeability and porosity. And a lot of these terms are thrown around loosely when it comes to all these different types of pavements. Just understand this. Permeability is the rate at which the water can flow through the concrete. Porosity is the percent voids. And why that's important is we have different mixes for different uses with different size aggregates. And I'll blow this up right here. If you look here on the left, this is our heavy duty mix. It's got 3/4 to 1 inch aggregate in it. And you can see it's much larger than these two mixes right here. Now they have color in them. This is a typical 3/8 mix. And then over here, this is the chips or the pea gravel. You can clearly see that all these mixes have different size aggregates. They all have the exact same porosity. All of these mixes have 20% porosity, but they have much different permeabilities because of the size of the aggregates. Large aggregate, large rocks, large holes, water goes through much quicker. Small aggregate, small holes, water goes through much slower. They all drain different rates. We see these small mixes on sidewalks or around pool decks because they're much easier on the bare feet. The 3/8 mix is most common. You'll see it on sidewalks, but a lot of driveways, a lot of pavements. And this is the heavy duty mix. We use these at firehouses and industrial areas and truck facilities. Now, how do we design the pervious concrete? This is the meat of today's webinar. So let's get into the pavement thickness itself. Remember, we have 20% voids in a pervious concrete. Therefore, our actual concrete thickness of pervious is roughly going to be 20% or 1 inch, we're finding, greater than it would have been if you went regular concrete. So for sidewalks all over the country are 4 inches thick. Pervious concrete, we're going to go 5. Driveways, residential roads, we're typically seeing 6. Heavy duty areas, we're typically seeing 8. Just to give you an idea. Now, in a minute, I'm going to show you how you can actually calculate that. But you never want to go less than 5 inches with pervious concrete. Because remember now, in regular concrete, we never want to go thinner than 4. And the rule of thumb is go 1 inch higher for the pervious. If you have very high point loads, say you have a crane or you have forklifts or you have some sort of specialty vehicle, you might want to consider not having impervious concrete, because we cannot put any rebar, any reinforcement into pervious concrete. Steel with the water means rust, corrosion. It will end up not working. I have gotten questions in the past if we wanted to use fiberglass reinforcement. The answer is yes, you can. If you really feel like you need it, once you see how much it's going to cost you and the lead time, you might want to rethink it, but it can be used if needed. Personally, haven't used any of them. I've been involved in well over 400 pervious concrete projects. We also cannot bridge really, really poor soils like you could with a reinforced concrete. But quite frankly, really, really poor soils probably won't be absorbing much water anyway. So it's not really to be considered there. Also, it's not in the slides, but you need to have a minimum of 2 feet above the high water table to the bottom of your stone for the system to work. Therefore, it's not really conducive to swampy areas. Those of you familiar with the MetLife Stadium where the New York Giants and Jets play, or Citi Field where the New York Mets play, both of those stadiums approached me about using pervious concrete, but they really couldn't because those areas are pretty much swamps and water would have nowhere to go. Now, as far as strength, I know I told you that we don't specify strength. And a typical pervious concrete mix with no fines is roughly around, let's just say 2,800 PSI. But now, let's say for whatever reason, you do need to have a stronger mix because it's more heavy duty use. So here's how you can get a stronger pervious concrete mix. You can use any one of the 4 things you see here, or combine them, or use all 4. The easiest thing you can do is just put some sand back in the mix. Now keep in mind, when you put sand in the mix, you're not going to be swapping porosity for strength. You never want to go less than, if it's a pavement, you never want to go less than 17% porosity. But by adding sand, you can get up to 1,000 PSI strength gain. But be very careful with that. I never go more than 300 pounds per yard, and it needs to be with the larger aggregate. The next thing you do, and I do this in all my mixes anyways, I put in synthetic macro fibers. They're the 2-inch long fibers. And what we have found is not only does that give you an additional strength bump, roughly around 200 to 400 PSI, but it actually gives you better resistance to freeze-thaw damage, which I'll be touching on later on. And another thing, which is kind of a weird anomaly, we found that when you add fibers to the mix, it actually holds the paste tighter to the stone. And if you look at your overall system, you'll get about a 4% increase in your permeability. Not enough to break the bank, but it's just a nice little side effect of using the fibers. Now, if you don't have ADA requirements, you can go with a larger aggregate. It'll be much rougher on the bare feet. It'll be really hard on wheelchairs or shopping carts. But the larger aggregate mixes give us a much higher strength, we found. And then lastly, you can just simply go an inch or 2 thicker if your budget will allow. So these are ways to get a stronger pervious concrete into your system if the need arises. Now I'm going to give you an example of how to do a pervious concrete design. So this is a very small parking lot for a apartment complex in Florida. You see the, what's it, 11, 18, around 20, 22 parking spaces. They wanted to add on to their existing parking lot. And the original spec was going with these grass pavers. They did not have a lot of success when they had tried it earlier because with the heat and the sandy soils present in this area, the grass wasn't taking in the grasscrete. So they wanted to look at pervious concrete. Now, typically you could go use ACI 330, which is the parking lot design program. Because I work for the NRMCA and I know how great it is, I'm going to refer you to pavementdesigner.org, which is our concrete design website. And you can go under the parking module, which will give you basically the ACI 330 design. But I'll show you how you can alter it for concrete, pervious concrete. So we go to the first page of the parking lot module. Going back real quick, this is just a small parking lot for cars. So that would fit under traffic spectrum A, which from ACI 330, car parking areas and access lanes. We're going to do a 30-year design life. I put 2 trucks per day. There's really not going to be any, but you might get a UPS truck that might turn around in there, possibly. But so I threw that in. So that's the first page of our pavement design. If you're not familiar with this program, we do offer a webinar on this, which I will touch on later on, that'll go into detail on how to use it. On the second page, if you have some information on your existing soils, I put in a California bearing ratio of 5, but if you look up here, there's other ways of specifying your soil strength. When it came to compressive strength for my concrete, now I put in 3,000. If you feel more comfortable with 2,800, you can put that in. If you feel more comfortable with 2,500, you can put that in. For my sub-base layer, this is my stone layer. I always start out with 6 inches because that's the minimum. Now I'm going to touch on the base here in a minute. But I put in 6. For my combined K value, I'm going to go to my ACI 330 table. I'm going to override what the program says and put in a more accurate number, which you see here. Again, I know I'm going fast, but if you're not familiar with this program, again, I'll refer you to a webinar that we offer on that. And finally, it's going to come up with a recommended design. It said 4.75. I'm going to round that up to 5 inches of pervious concrete for that parking lot. So now I know how thick my concrete's going to be, at least as a minimum. Remember, this is a system. We don't stop here, because the water's going to go through the concrete and has to go somewhere. So now we need to design the base that's going to store the water until it can absorb in the ground. Now, there's several ways to do it, but the easiest way that I know and that I use all the time is to use the design program, which you see here. Now, you can purchase it from the bookstore. However, the bookstore is closed right now. And as a thank you for attending this webinar, you can download it for free in the handout section of this webinar. If you look over there, it's an Excel-based program. It is very easy to use, and I'm going to run through it with you. I appreciate you being on this webinar. So take this gift, and hopefully it'll help you with your designs. When you get into the program, the first thing you're going to want is the data input sheet, and it's going to look like this. The top part, you just fill in the name of the project, the date you're running it. Next, we're going to put in the thickness of the concrete we just calculated there, the square footage, and the porosity. And typically, the mixes have 20%, so I put in 20% porosity. Now, for my gravel base, I start with 6 inches. Now, I'm going to tell you that if you have a parking lot that the soils are anywhere above 2 inches per hour infiltration rate, 6 inches should do it, unless you have a lot of other areas draining into it. When you get less than 2 inches per hour infiltration, you might be going up to 8. I know there's a lot of areas that you'll probably be in the 12-inch range, but you're going to see 90% of your projects are going to be somewhere between 6 and 12 inches of a base. I put in 6 inches here. Now, your clean aggregates average around 40% voids. Your supplier of the aggregates can give you the exact number, but if you're just running a calculation, you put in 40, you should be pretty safe. The next number here is called ponding limit. Now, this is a very important point. If you have an area that experiences any freeze thaw, your ponding limit needs to be 0. What ponding limit is how much water can actually come out of the concrete and be stored before it gets absorbed in to the ground. Here's my example. If anybody's ever been to Florida in the summertime, it'll be sunny all day. Around 5 o'clock, you'll get a thunderstorm, the likes you've never seen before, and for 20 minutes, it'll rain so hard you can barely see. And then the sun comes back out. In Florida, the way they design their systems, they take the height of the curb in the parking lot and they utilize that as additional storage, which we call ponding limit. So you can have up to, if you have a 6-inch curb, you could have up to 6 inches of additional storage on top of the concrete. So for those areas in the country that are paying attention to this webinar, that do not have any freeze thaw, you can allow the water to come out. If you do have freeze thaw, I don't recommend you use a ponding limit, because I want to limit how much water is actually in the concrete that could possibly freeze. And we'll touch on that here in a little bit. I put in the exfiltration rate of the soil, which from the perk test we got was 2.5 inches per hour. Now, if there is any impervious surface that is draining into your pervious concrete, you would put that in there. You see a lot of designs where they do the parking stalls in pervious concrete and then the drive lanes in either asphalt or traditional concrete. And those areas drain into the pervious. If you do have it, you would put it there. And then lastly, if there's any off-site drainage, say a lawn, a berm, possibly even a roof leader going into it, you can put that in. And then if you're not familiar with the CN number, it's just the runoff coefficient for the type of area that's draining. 61 is usually a lawn area. Next, you need to know what design your storm. Now, most municipalities that I deal with are either asked for a 10 or 25-year storm event. I always design, unless I have no other choice, I design for the 100-year storm event. Therefore, I'm covered if they ever change the rules. Like in my younger days as an engineer, I designed for a 10-year storm, and then they would change the rules to 25, and then everything would be under designed. So if you put in a 100-year storm, in a lot of cases, you'll be good for your career. For this part of Florida, the 100-year storm was 9.25. Now, over here where you see rainfall info, you can click on that, and it gives you every state in the country up to the 25-year storm. But you'll find if you go to the NOAA, the National Weather Service website, they actually give you precipitations for everywhere in the country. Time will not allow me to go through that whole query search with you, but many counties also publish the storm events. When you get all that together, you're going to go over here where it says results. And when you hit on results, you're going to get these 4 options here. And the first one I always go to is the graph sheet, because that's going to tell me right away if I have enough stone. So when you go to the graph sheet, here's what you're going to see. Now, these call outs I have here, that's not normally there. I put those there so you can understand what you're looking at. Down here is the bottom of your stone base. Here's the top of your stone base. Here's the top of your concrete. And because we have a ponding limit, that's the ponding limit right there. These blue lines represent the intensity of my storm. And lastly, this blue line right here shows me where the water levels are during my storm. And you can see right here that at the 100-year storm, the water stops about 1 inch below my concrete. So I can contain the 100-year storm within my section of 5 inches of concrete and 6 inches of stone. If I had run this and you saw this blue line out here, that meant my stone layer wasn't deep enough. I need to go back and rerun it and put in a different number. So that's what the graph looks like. Then also, you can go to the results sheet. And in the results sheets, I had to break this up so you can see it. The top part of it is just the initial information that you input, and that'll be in the green. When you get down to the bottom on the summary results, when you look at maximum ponding depth, -6, that means it's 6 inches below the top of my concrete. I had 5 inches of concrete, so now I am in my stone layer. And if you look at total runoff, it's 0. That means my entire 100-year storm has been contained. So that's how the software works. And you'll see it as you run it, it's really easy to use. If you try it out, you have any questions, feel free to reach out to me. I can walk you through it. I can check your work for you. I'll be touching on that later on and how we can give you free assistance with that. But you'll find it's a very easy system to design once you understand that it's different than just a regular pavement design. Also, one of your handouts you can download, I'm giving you some PDFs of typical details for pervious concrete. You're going to see here, this is going to give you a section that's just plain without joints. This is a construction joint, and this is your contraction joint. I will tell you this, pervious concrete doesn't have to be jointed. what we call the West Coast design. There's a lot of people west of the Mississippi. They just let it crack naturally. Remember, it has that Rice Krispie treat texture. And with that texture, you won't see the cracks. Matter of fact, the patio of my house, I didn't put any joints in it. It took about 6 years for some cracks to show up about where I thought they would be, but they're really tough to see. It's more of a rustic look. If you want to control where the cracks are, if you do think that's important to you, then we can put joints in. 2 webinars from now, we're going to be doing construction of pervious concrete, which I'll explain the difference in putting in a pervious concrete joint as compared to a regular concrete joint. So please tune into that in 2 weeks. Now, there are many ways to utilize this system to actually capture that stormwater and reuse it. In this world of green engineering and environmental engineering, we can put in a system within the pervious concrete to capture that water and reuse it for irrigation or gray water in the toilets. Here's an example I'm going to show you. They make these, I call them chambers. It's basically a perforated pipe cut in half. As far as storage goes, remember the stone has 40% voids to store water, but underneath that pipe in this area, it's 100% void. Light rainfall will get between the pipes and go into the ground, but heavy rainfall, the water starts to fill up and then goes into those chambers, where it can either give you additional storage, or in this video I'm about to show you in Atlanta, they captured the water and reused it for irrigation. So they switched to a pervious concrete system, as you see here. Water that didn't go into the ground went into the pipes. They collected it to a cistern, and it used it to water the grass. In a minute, the grass is going to grow, and the trees are going to bloom, and the flowers and the children are going to sing, and it's a happy Atlanta library. So you can see there's ways that you can utilize some piping within the system to actually help you with your overall project. Now, the cool thing about pervious concrete is you can pave completely flat with no grade, and you'll never have to worry about bird baths because the water will go straight down. However, the world isn't flat. You may be in an area that's on a hill. And what happens is, if you don't alter your base, you can run into a situation where water will run downhill and actually start seeping out of the concrete, and then you'll have some of the stone base that's not being used. So how do you alter the base on this slope? Well, the 2 ways to do it are either to build in dams on your slope that will contain water in chambers, or you're going to have to tier your base. And that way water will not run downhill. It will have a chance to get into the ground. And within those details that I've given you today to download are details on how to do both of those. You can also incorporate, if you need to, perforated pipes that will allow it to daylight off to the side within each of the chambers. And how that's constructed is simple, as you see here in this slide. Either you can pour a concrete curb. I call these header curbs. The top of the curb is equal to the top of the pavement, which makes these chambers and the water can't go any further. Or within your stone recharge bed, you can put in sections of an impervious type of stone, a modified stone with lots of fines that are packed in, and it will give you chambers that will hold the water. Again, you want to keep it from running downhill and then popping back out of your concrete pavement. You can go ahead and paint lines, even if you have, like, say, the handicapped area that's completely sealed up with paint. There's enough surface area around that that will absorb the water. We can put color into it. We can even stamp the concrete. It's not going to look as great as traditional concrete that's stamped, but you can get a texture to it. City of Philadelphia loves doing colored, stamped, pervious concrete. Been on probably half dozen projects with the water department where they've done that. Those of you that were fortunate to get to China in 2008 for the Olympics, the entire Olympic Village was paved with colored pervious concrete, and Concrete Decor magazine did a whole article on it if you really want to do some research on it. All right, now, the 3 most popular questions that you get on pervious concrete, I'm going to cover them right here. in no particular order. Let's deal with freeze thaw. A lot of people say, well, I don't want to use pervious concrete. It won't work in the winter because once it freezes, it's going to expand and blow up. Well, let's talk about what we know already. All right. First off, we have 20% voids in the mix. So if there is water that gets caught in the concrete and freezes, there's plenty of elbow room. But we also know that if we design this properly, the water will run through it so quickly and go into the stone layer below that we shouldn't have much water, if any, actually in the pervious concrete. That said, the mixes that we use now are so strong, and we have study after study, that you can fully saturate them, and they will go through 300 freeze-thaw cycles completely saturated before they start to show any damage. So this concrete actually works very well in wintertime conditions. Now, we can protect it and help it by putting seal coats on it, which we will cover more in the maintenance webinar next week, and I'll briefly touch on it today. Here's the cool thing about pervious concrete in the winter. Those of you that have wintertime understand the term black ice. Snow gets plowed into piles, the sun comes out, it starts to melt, you get water that slowly trickles downhill towards an inlet, then at night it freezes into a real thin layer, which you can't hardly see. You walk out to your car at night, you slip, you fall on your rear end, you're in the hospital, or your car slides around. When you go with pervious concrete and they plow it up in the piles and it starts to melt, it goes straight into the ground. You do not get the black ice. In fact, in light snowfalls, as you start walking and driving on it, and you start driving that snow into the pervious concrete, it just disappears. It's actually really, really safe in the winter, which is why so many schools, retirement communities, municipalities like it in a sidewalk. Now, maintenance. Yes, it can get dirty. Yes, it can clog. But just like your face, if your face gets dirty, you take a shower. When the pervious concrete gets dirty, and this is the only one of all the pervious pavements out there I can say this about, this gets dirty in the top eighth of an inch, and it is very easy to clean. Now, I'm not going to get, I actually have 8 or 9 slides on maintenance. We're going to cover those more next week. But just so you know that a leaf blower, a broom, power washing, a vacuum, all this, how often do you do it? Well, just directly proportional to how much crap you got falling on your pavement. I usually do 1 power washing in the spring after last snowfall, and then I just use a leaf blower after that. And I found that's been fine. It's worked in my pavement now for 6-7 years, and it still drains great. Big vacuum sweepers work fine. If you want more information, if you go to our website, which I'll touch on in a minute, we have, I call it the Bible. We have the maintenance guide that's in there that will explain in detail how to maintain the pervious concrete. It is not hard. Matter of fact, for most of the industrial places, when they have the person who's mowing the lawn, if they just come out there and hit it with the leaf blower, they're doing maintenance. It's that easy. I'm going to skip over some of this because of time. One thing I do want to kind of hit home with you is the most damage I see, and this is what these past slides were throwing down the wrong kind of salt on pervious concrete. Pervious concrete cannot take anything with magnesium in it. And this is just an example of an owner that didn't pay attention, and they threw down something with magnesium, and that caused a big problem here. I do recommend that you use some sort of silane, siloxane blended sealer on top of all your concrete, be it regular concrete or pervious, just to protect yourself from de-icing chemicals in areas where you apply it. It really helps. There's actually some polymer additives, which I didn't touch on, that also help with wintertime defense of de-icing chemicals. There are lots of places in the country that instead of throwing down salt, they just throw down a coarse sand and then in the spring vacuum it up. So that's something to consider in wintertime. All right. Where's the rubber hit the road? How much is this going to cost me? Now, depending on where you are in the country, it could be higher or lower. There are some places where it's the same price. when you're just looking at how much a cubic yard of pervious concrete costs compared to a cubic yard of regular concrete, it's running anywhere about 5 to 10% higher. But see, keep in mind, remember I said you want to take concrete out of the definition here? This is a system, all right? And because it's a system, you can't just look at your pavement costs. You have to look at the entire site. And here's what I mean by that. If I take a simple example of this parking lot, 100,000 square feet, and I only look at the pavement price, I compare the concrete, 6 inches of concrete over 12 inches of an aggregate base, compared to the asphalt design, and stop right there. I'll say, well, my concrete costs too much. Why would I ever use it? Remember, this is a system. So let's go from, instead of apples to oranges, let's get it to apples. So on the left is my pervious concrete, which is also my stormwater. On the right there's my pavement. Now let's add in the infrastructure. And don't forget how much that land costs that is non-usable. This is why so many developers now are looking at pervious pavements going, I can get rid of that pond, that 2-acre pond. I could still have all the stormwater benefits of it. And now I could put in 2 more buildings, or a lot of developers can get in 10 more homes in a subdivision because they can still deal with the stormwater, still meet all the requirements, yet don't have to pay as much for all that extra infrastructure. So keep that in mind. Now, I have countless project examples I can show you. I just want to show you a couple, and you'll see why I picked these. The first one was this park in North Jersey I mentioned earlier. It was put in 2009. Not 6 months after this park was put in, I don't know if you can see this right here. There's a bridge. That's the Passaic River right there. On St. Patty's Day of 2010, they had the 500-year storm. They had a catastrophic flood. And if you see this here, that park I showed you was way behind those basketball courts. It was underwater for almost a month. And when the water receded, the entire pervious concrete system was plugged up with Passaic River muck. And if you ever watch The Sopranos, you kind of know what would be in the Passaic River. They power washed the entire park and got it to drain again. Worked very well with just the power washing. The other disaster, if you paid attention to the news back early part of the teens here, we had Superstorm Sandy. Hurricane Sandy hit New Jersey and devastated the Jersey Shore. We had just put in a fishing pier in pervious concrete, which is right there, which was really ground zero of the hurricane. And again, we pressure washed the pier and we got the pervious concrete to perform again. So you can completely muck it up with the worst disasters imaginable, yet you can clean the top and it comes right back to life. None of the other pervious pavements that exist can say that or will have that happen. The last example I want to show you is the World Trade Center site, the ground zero there. Now, this is a totally different use of pervious concrete that I'm starting to see more and more. The pervious concrete is actually used as a base underneath decorative pavers. So you get the strength, porosity, and durability of a pervious concrete. Then you put the paver on top to give you the look of the pavers. And what they do is they just don't fill the gaps between the stones, or they'll put a pea gravel in there. Either way, we're seeing this more and more, and this may come up in your area. Now, the last part I want to cover is certification and training. Because pervious concrete is so different, the specifications that we use for pervious concrete specifically say that the contractor and the ready-mix producer need to be trained and certified in pervious concrete. The NRMCA and the states in each of your areas offer these classes. I am one of the instructors. I actually travel the country and teach this class. And it's very important that you have someone that understands this, because all too often you get a contractor who's never used it. They're going to try to finish it like regular concrete, and they'll seal up the holes and it won't drain. Or you'll get a producer that doesn't understand how to deliver it. If they jump ahead here, and you'll get a mix that doesn't drain. We had this problem in New York City, so we had to get them up to speed. We have actual manuals you can refer to. On the left, the blue book, which you can get to on our website, which I'll show you in a minute, is a free download. On the right is the contractor training manual. If you take a class, you will get that book as part of the class. 2 webinars from now, I'll be covering the installation, which is the bulk of what that book has to say on that. You can reach out to me if you need some information on that. All right, so to round this out, I want to let you know the resources that the National Ready Mix Concrete Association has that are available to you. And the key word in this is right here, free. These are free services we have for you. And the first thing I want to refer you to is our website, paveahead.com. And when you get there, you're going to find, first off, there's a section of resources. And when you get into resources, you can see all the different topics that are there, and specifically Pervious concrete. A lot of what I mentioned to you today is available under the resource section, as well as not only the handouts that you can get from this webinar, but we also will refer you to our Concrete in Practice series, where you can get some additional information on a wide range of topics in concrete. You can also get to our Pervious in Practice series. Pervious in Practice 1 is part of your handout, but we have several others. You'll find those all in our resource section. Now, we also have a really, really cool button right there, our Design Center. And what we can do for you at the National Ready Mix Concrete Association is offer you free design assistance, not only in Pervious concrete, but also in any other paving concrete application. All you got to do is ask. Get us enough information. We will turn around and give you a report that will give you recommended thicknesses. We can give you details. We can give you specifications. Now, keep in mind, we are a trade organization. And even though we're professional engineers, we're not the engineer of record. So you're going to have to give this to your engineer of record for final approval. But it's a free service for you. And we have people all across the country that can help you out. Our department head, who is on this call, is Brian Killingsworth, you see there. And then the first page is, I call it our Pennsylvania team. You see I cover the Midwest, Luke has Northeast, and Phil has the Mid-Atlantic, and all 3 of us are based in Pennsylvania. Our non-Pennsylvania team here, John Hansen has the West, Amanda the South, and Don, the part of the country I love the most, the mountains up there. We have people that can help you, and you can see that most of us are engineers, and those that aren't have been in the business longer than I've been alive. So we are great resources for you. You can email us, you can call us, anything you need, we are there for you. To round this out, today was our Designing Pervious Concrete. You see the next 3 weeks, we have more Pervious Concrete that'll delve more in detail in some of the things I just kind of glossed over. But we also have other webinars. We've already given them, but you can download them if you go to the Portland Cement Association, as you see there. And on the next page, these are the ones you may or may not have attended over the past 2 months since this COVID crisis started. These recordings are available for you. Now, lastly, we also have, I'm in the paving group, we also have a buildings group who also has a whole series of webinars. And if you're interested in concrete building, you can go to their website down here, which is Build with Strength, and you can get information on them. Again, our downloads, if you go to the education section under Pave Ahead, under Build with Strength, you can go to their education section and get information on their webinars. I think I got that in under an hour, right on the button. So if you have any questions, I didn't see any pop up on the chat section, but you have my contact information. You can reach out to me afterwards. I'll be happy to help you out. The past couple months, especially, I've had a lot of Pervious concrete projects come across our desk. I know New Orleans is really ramping up with it. I know New Jersey's been ramping up with it. I'm currently working on a project in Delaware for Delaware DOT. It is being used all over the country. Do not feel like it's only a southern or warm weather type of pavement.
Hey,
Thank you
Ken.
very much.
Ken, we
And
actually do have many questions in the Q&A box. Unfortunately, we don't have time to answer those. But what we will do is within about a week or so, we will post the questions and the answers to our paveahead.com/education page under the title of the webinar that we've presented today. Along with that will be a recording of the webinar and also a download of the slides, a PDF of the slides. So we'll have that up, the slides and the recording within a couple of days, and the Q&A within about a week or two.
okay. Thank you, Brian.
All right. Thank y'all.
Everybody have a good week.